So anyone who's seen us at Accrington in 2024, 2025 will have seen the Thunderbird rocket engines in action. First off, these are all electrical. I don't really like incendiaries and flares and burny things on a track that's made out of straw bales, so we do it electrically. We can also time things a bit better doing it that way. That said, there are inherent dangers with the electrical approach, the main one of which is pressurised liquids at 300 Celsius. So if you want to experiment with this stuff, extreme caution. This is one of our little safety features here, which we shall disengage for this test that we're going to run. So the core of the system is essentially two disco type smoke machines embedded into the soapbox, and they sit in here running at 300 degrees centigrade. They're an aluminium block that we heat up and stores an awful lot of energy, hence the stainless steel structures, the heat insulation, the heat shields, to protect these things, which, yes, they are plastic flower pots. So what we do is, to create our smoke effect, we inject what's essentially vaping mixture into the aluminium down this little narrow pipe here. Once the mixture hits the 300 degrees Celsius aluminium, it decomposes into essentially water vapour. So we've got all manner of wires and rat's nest going on under there. That's to do with maintaining the temperature safely. We've got a big long pipe here that runs the fuel. There is the rocket fuel in the tank, and here are the avionics that controls the whole show. So we use avionics here because what we can do is, at the start, our brave driver hits the start button, we get a countdown, and after that everything's fully automatic. Running the avionics, we've gone for a LiPo this year. We did run lead acid on here, but that came with a few problems, so we're trying this out for 2026. In there you can see the little Arduino that runs the show, and we actually have a fueling map, just like on the other videos on the channel about the RX-7. We have a fuel map, very similar thing. So what we do is, for every second of the 25 seconds we reckon the race will run, we map the fuel pressure we want to supply out to the rocket engines. So the little Arduino controls via the green wire this fuel pump under here. Fuel runs down from the rocket fuel, down the pipe, into the fuel pump, and the fuel pump is under control of this power MOSFET right here. That's how we drive the fuel pump. This is the master power relay. Just to keep things safe, we can isolate all the power electrics, that's the fuel pump and the heaters at the back. So if you've seen us on race days 2024, 2025, you might have seen us scrabbling around with the start cart here. Now the start cart contains an enormous lead acid battery, and we use that to preheat the rocket engine, so you'll see us in the pit lane. Down in here we've got relays that switch out when we hit the temperature we want. A couple of little indicators to let us know what's going on. So that's what we're doing. If you see us in the pits scrabbling around with sinister looking wires and so on, we're warming things up. Okay, so start cart removed, access panel replaced, rocket engines are hot, and we're now running on internal power, relying on the LiPo to keep everything nice and warm. So I can run you through. This is the master arm key here, so we'll keep that in a safe position. We can run through what the driver sees. So at the start, we'll hit this button, we get our little countdown, and we watch for some bars here. So these bars indicate preparing to firing. And then we wait a bit, again, build up, firing. That's under the control of the map. And then again for the final time, which hopefully is the end of the race. Okay, let's turn the master arm switch. Master arm light comes on. master power relay has enabled power out to the fuel pump and the motors. So this is now ready to fire. Let's give it a test, see what happens.